This video is a test review for Module 4 covering the topics of equations of linear functions. Question 1. Write an equation of the line in slope-intercept form that passes through the given point and has the given slope. So slope-intercept form is y equals mx plus b. So that's the form we want to put our equation in. So if we're given a point, this would be our x, this is our y, and we have our slope of 3, so that would be our m. So we need to find the y-intercept, which is our b. So to do that, we're going to put 5 in for y, equaling, we're going to put our slope, and our slope is 3, times our x, which is 7, plus b. 3 times 7 is 21, plus b is going to equal 5. To get b by itself, we're going to subtract 21. And our y-intercept is going to be a negative 16. So our equation in y equals mx plus b would be y equals our slope of 3 and our y-intercept of a negative 16. So y equals 3x minus 16. Question 2. In the first quarter of 2012, there were 183 million users of a popular social media site in North America. The number of users increased by an average of 9 million per year since 2012. Write an equation that represents the number of users in millions of the social media site in North America after 2012. So we're going to put this in slope-intercept form. To do that, we have a point. So the point where we have 2012 and 183 million, but we're not going to use 2012 because at the very end it says the years, like we're writing an equation that represents the number of users in millions of the social media site in North America after 2012. So 2012 is actually 0 years after 2012. So that part will be our y-intercept of 183 million. The rate of change, which would be our slope, they're saying that it's increased by an average of 9 million per year. So our equation would actually be y equals our slope or a change would be 9 million. We're just going to use 9, x, and then it'd be plus 183. And just keep in mind that these are numbers in millions. Question 3. Write an equation in point slope form that passes through the following pair of points. So negative 5, 4 and negative 2, 6. So point slope form is y minus y1 equals m times x minus x1. So we have 2 points. We're going to use these 2 points with the slope formula of y2 minus y1 divided by x2 minus x1. So that's our first step. So this is going to be my x1, y1, x2, y2. I'm going to have 6 minus 4 divided by negative 2 minus a negative 5, which is going to give us a 2 in the numerator. And negative 2 minus a negative 5 is really negative 2 plus 5, which will give us 3. So we have a slope of 2/3. So I'm going to use that for my m. And then all I have to do is pick one of these 2 points to put in for my y1 and x1. I'll write both possible answers. The first one using this point. So I would have y minus 4 equals our slope of 2/3 times x. Now if I have minus a negative 5 really means plus 5. So that would be one possible solution you could have. If you use the other point, then you would have y minus 6 equals 2/3 times x, And instead of, when you're subtracting a negative 2, you're really adding 2. So those are the two possible answers you could have to write the equation in point-slope form that crosses through those 2 points. Question 4. Use the graph to write an equation of a line in point-slope form. So we're going to use the same formula. Here, since they've given us a graph, they gave us the graph, they gave us a point, and they gave us a slope. So all I'm going to do is plug those into my formula. So I would have y minus, and this would be my x, and this is my y, or I should say x1, y1. So it'd be y minus 2 equals our slope of 3 times be x minus, and our x1 is 1. So that would be our point-slope form equation. Question 5. Write an equation in standard form. Now remember, for standard form is an ax plus by equals c format, and a has to be positive, and a, b, and c all must be integers. So we cannot have any fractions or decimals. So here I do have a fraction. So to get rid of this fraction, and I don't see any parentheses, I'm going to multiply every piece by 3. So I have 3 times y, which is 3y, equaling 3 times 5 is 15, divided by 3 is 5x, minus 3 times 1 is 3. From here, I look at what I have. My x term is positive. That's where my a is, because my a is always with the x term. I need to keep that positive. That means I don't want this minus 3 here. So the opposite of subtracting 3 is adding 3. So now I have 3 plus 3y equaling 5x. Now I need my y on the same side as my x, so I'm going to subtract 3y. So I would have an equation in standard form of 3 equaling 5x minus 3y. Or if you want to put it the other way, it could be 5x minus 3y equaling 3. Question 6. Write the equation in standard form. So here I have point-slope form. I need to put it in standard form. I don't have fractions in here, but I do have parentheses. And I need to get rid of the parentheses by distributing the negative 2. So right now I have y minus 6 equals a negative 2x, and negative 2 times 7 is a minus 14. Now I need my x term to be positive. Right now it's negative. So I'm going to add 2x to both sides. And now I have 2x plus 1y minus 2 equals a negative 14. Now I don't want this minus 2 here, so I'm going to add 2 to both sides. And in standard form, I have 2x plus 1y equals a negative 12. Question 7. Write an equation in slope-intercept form for the line that passes through 8, 2 and is parallel to the graph of y equals 1/2 x plus 1. So parallel lines have the same slope. So if they have the same slope, the new line has to have a slope of 1/2 because this line has 1/2. Here's my x and here's my y. So I'm going to have 2 equaling 1/2 times my x, which is 8, plus 1. So we have 2 equaling half of 8 is 4, plus 1. Actually, I don't need this plus 1. Sorry, this is plus b, because we have to find the new y-intercept. So this would be plus b. To get b by itself, I would subtract 4, and I would have b equaling a negative 2. So my equation that's parallel to the given line would be y equals the same slope of 1/2 x and a new y-intercept of -2. Question 8, write an equation in slope-intercept form for the line that passes through 3, 1 and is perpendicular to the graph of y equals 5/2 x minus 6. Perpendicular lines, they cross at a 90-degree angle, which means the slopes are negative reciprocals. So negative reciprocal. So if I have 5/2, I would have to flip it, which is 2/5, and I take the opposite sign. So the opposite of a positive is a negative. So the new equation is going to have a negative slope. So then I'd use my x and y. So here's my x and here's my y. So I have 1 equals negative 2/5 times my x term, which is 3, plus b, because I need to find my y-intercept. So I have negative 2/5 times 3, which is negative 6/5, plus b. And this is going to equal 1, but since I have fractions, I want to rewrite 1 so that they have a denominator of 5. So I would have to multiply that by 5/5, which 5/5, 5 divided by 5 is 1. So those two numbers are equivalent. Now I can get b by itself by adding 6/5 to both sides. And I would have a y-intercept of 11/5. So the perpendicular line would have an equation of y equals a negative 2/5 x plus 11/5. Question 9. The scatter plot displays the miles of bike lanes within a city in relation to population. Determine whether the scatter plot shows a positive, negative, or no correlation. If the correlation is positive or negative, describe its meaning in the situation. So if it's got correlation, there's going to be a pattern in the points. Positive means they are going to be a pattern where the points are going up in like it'll go up in a tightly packed manner, going up from left to right. Negative would be going down from left to right. Now, if you look at our scatter plot, there is no pattern. So since there's no pattern, we would say this has no correlation. Question 10. Does the correlation in this situation below illustrate causation? And then we need to explain. Ava researched data from the state police website and found a positive correlation between cell phone use while driving and car accidents. So is there a correlation? So they're saying that the more there's a positive correlation, so the more people are using their cell phones while they're driving, there has been a case where there's been more accidents. Now, is that the reason why they have car accidents? I would say no. And the reason why I would say no is because there are many reasons for car accidents. And some of those reasons, it could be the weather, it could be people who are driving under the influence, so there's drunk driving. It could be there could be construction going on, and then some people may not be paying attention as they're driving. So there's more than one reason for why there's car accidents. This one, they're saying that it's because of cell phone use. That is not the main, we can't say definitely that that's the main cause for car accidents. Question 11. Each year, a basketball tournament featuring 68 college basketball teams takes place to determine the national champion of Division I college basketball. The table shows the revenue generated through ticket sales during the NCAA college basketball tournament from 2006 to 2013. So we can see the table with the years as our X and the revenues, money that they brought in as your Y. So we're going to use a graphing calculator to write the line of best fit. We're going to find out what the correlation coefficient is, and then we're going to use the equation to predict the revenue sales in 2025. Now for any of these problems, if your X is going to be years, we're not going to use the years as our X term. We're going to put those numbers in. We're going to put down how many years is it from the given year to the starting point. So everything is based off of 2006. So 2006 is 0 years from 2006. 2007 is 1 year from 2006. And then 2008 is 2, then 3, 4, 5, 6, and then 7 years. So these are the X terms we're going to be using, and the revenue is going to be our Y coordinates. So we're going to grab our calculator, and the first thing we want to do is just make sure our diagnostic is on. So to make sure that it's on, I would hit second, 0, and we get a catalog. We're going to scroll all the way down until we see diagnostic on. So here's diagnostic on. We hit enter again, and when you see done, then you're good. So we need to enter the data into a table. So we hit stat, edit, and we have to make sure we don't have anything in our tables. If you do, just go up to L1, hit clear, hit enter, and you can do that same thing for L2. So now I'm going to put the X terms in L1. So we got 0, enter, and make sure you put enter after each time. 1, enter, 2, enter, 3, enter, 4, we got 5, we got 6, and we have 7. Now that I have those numbers in, I go to L2 and I'm going to type in the numbers. So we got 41.2, enter. We got 47, enter. We have 51.45, enter. 62.67, enter. 62.31, enter. 65.02, enter. 67.18, enter, and our last number is 71.71, enter. Once you have entered all the numbers into your calculator, we need to find the line of best fit. So to do that, we're going to hit stat, we're going to go to calculate, and since this is linear, we're going to go to linear regression, which is number 4, and then we're going to hit enter. Now here they give us our equation. We're going to round this to the nearest hundredth for our A and our B. So let me write our equation down. So it would be y equals 4.22x plus, and our B, or y-intercept, is 43.78. So 43.78. And our correlation coefficient is our R, and we're going to round that to the nearest thousandth, so 3 decimal places. So 3 decimal places would be 0.965. So I'll do 0.965 because this 5 tells us to round this 4 up to 5. So 0.965. Now we're going to use the equation to predict the revenue from ticket sales in 2025. So we need to know how many years after 2006 is 2025. That means the years would be 16, or not 16, 19. So X would actually be 19. So I'm going to find out what Y is. So we have 4.22 times 19 plus 43.78. So we can easily put this in our calculator. So we have 4.22 times 19 plus 43.78. That's going to give us 123.96. Now, again, this is in millions of dollars. So this is not $123.96. This is all in the millions. And our last question, question 12. The table and scatter plot show the revenue of a company from 2015 to 2020. The line of fit represents the predicted revenue Y in millions of dollars X years after 2015. Find the residuals and complete the statements. Now again, review residuals is the distance from the predicted to the actual. So what they gave us in the graph here, the line is the predicted value, and the points are the actual. So what we're going to be doing is we're going to put in the X term for the years since 2015 in for X to find the distance from the predicted amount, the line, to the actual. And the answer to that would be our residual. So everything X represents the years after 2015. So after 2015, 2015 is 1 year, 2016 is 2, 2016 is 3, and then this is 4, 5, and 6. So we're not going to worry about these. So now if I put 1 in for X, actually 2015 is 0, so I got those wrong. 2015 is 0 years. So we have 0, and then this is 1, 2, 3, 4, and 5. So now we're going to put in those numbers. So I have 8.2 times 1, which is 8.2, but I'm just going to put times 1, and then we're going to add 573.3, and that's going to give us 581.5. So I'm going to do minus 581.5. I'm going to put all these down and then I'll do the subtraction afterwards. So then the next one, we put a 2 in, or actually had that one wrong because I forgot to put, I had to put a 0 in here. So if I put a 0 in there, that's just going to give me 8.2 times 0 is 0, plus 573.3 is 573.3. So minus 573.3. The next one I put a 1 in, which would be 8.2 times 1 plus 573.3 gives you 581.5. Then for 2017, we're going to put a 3 in, or a 2 in there. So we have 8.2 times 2 plus 573.3 gives us 589.7. Then our next one, we're going to put a 3 in for X. So we have 8.2 times 3 plus 573.3 gives us 597.9. Then our next one, we have a 4 in for X, so 8.2 times a 4 plus So plus 573.3 gives us 606.1. And our last one, we put a 5 in, so 8.2 times 5 plus 573.3. That gives us 614.3. Now we have to just do the subtraction to find the residuals. So our first one, we have 553.9 minus 573.3. That gives us a negative 19.4. Next one, we have 591.7 minus 581.5 gives us 10.2. Next one, we have 601.4 minus 589.7. It gives us 11.7. Next, we have 605.8 minus 597.9 gives us 7.9. The next one, we got 612.5 minus 606.1. That's 6.4. And our last one, we have 598.2 minus 614.3. And that gives us a negative 16.1. So now we can answer the questions on the right. How many positive residuals? So I got 1, 2, 3, 4 positives. Negatives, I got the first one and the last one, so that's 2. The smallest residual, which means which one is closest to 0. The smallest one is 6.4, and that one happened in the year 2019. And the largest residual, the one that's furthest away from 0, is a negative 19.4, or you could say it, since it says distance, we're not going to use the negative, we're just going to keep it as positive. And that happened in the year 2015. Now, does the largest residual correspond to an outlier in the data? Now, for it to be an outlier, it has to be extremely large compared to all the other numbers. Now, the next closest is a negative 16.1, which is not that far away from 19.4. So for this one, I would say no, this one does not correspond to an outlier because that number is fairly close to all the other ones. So as a review on Module 4, working with equations and linear functions.